This is lesson number 65, Algebra 2, Advanced Substitution. So, what we're going to do here is I'm just going to take this picture that I have from the book, make it bigger, and we're going to use it, since if I were to write this out, it'd be huge. Alright, so we have four equations there, and what we're trying to do is we're trying to find the values of all four of the variables, the RW, the TW, the RB, and the TB. Those are our four different variables. Well, what did they give us? 1, 2, 3, 4 equations. So because they gave us four equations, we'll be able to go ahead and find the answer to our four variables there. So that makes it nice. But what in the world do I do with this? Alright, so what we're going to do is we're going to look at an equation to be our base equation. Now we'll pick one of those two since they have they aren't set equal to one variable. So see, like this one here, we have RB equals this and TB equals this. Those are set equal to one variable. So we're going to use these to substitute later. But right now we're going to use one of these two equations as our base equation. So let's use the second one because that's what the book does. And so we're going to use that as our base equation. And we're going to do some substitution because in order to solve this, we have to get rid of one of the variables, because you cannot solve for two variables in one equation. So we're going to have to use substitution to try to get this to be one variable here, so we can solve for that and then solve for the rest of them. So that's the hardest thing. So what we're going to do is we're going to take and substitute 3r of w in for this rb here, since that's what rb equals. So I'm going to rewrite that as 3rw for that rb. And I'm also going to substitute this tb with that over there. So I'm going to multiply it by 2 minus tw, and then that equals 6. Then I distribute. Okay, so I get that, except I'm getting a little ahead of myself. Actually, there is this RW in there too. I forgot to put that in there. Okay, so now I've got it right. Alright, so now let's see if there's anything else I can substitute. This is a variable. I have two variables here. I like the RW, but I don't like this TW. So RWTW equals 6. So I can replace that with 6. Oops, I don't know why I put a negative or a positive there. So instead of this here, I'm going to look here and I'm going to put a 6 there. Add 18. 6rw equals 24, divide by 6, and my rw equals 4. Okay, so I found out what one of my variables are. So now I can take this and I can plug it in. So I can take that 4 and plug it in here. So this is going to be 4tw equals 6. So 4 divide by 4, and TW equals 3/2. So I've got a TW and I've got an RW. Okay, now I have to go on and find my RB. So I'm going to take that one. And what is RW? It's 4. So RB then equals 12. And then, let's see, since my RB is 12, and I've got a TW and I've got an RW, now I need to find this TB. So I'm going to put 12 in here, times TB equals 6, and then my TB then will equal 1/2. So instead of an RB, I'll put a 12, and then TB is what I'm looking for, equals 6. divide by 12, and I get TB equals 1/2. So I just found all 4 variables that way. So it all looks real nice and easy, but then when you're given one, they get a little bit tricky. So let's go ahead and keep moving as far as trying some of these. So let's look at example 65.2. Alright, so again, we're trying to get one of these equations to only have one variable, so we can solve for the one variable, and then we can plug in and solve for the other 3. But that is the key thing here. Use any one you want for the base variable or the base equation. Replace by using substitution, and then go ahead and get it down to one variable. And it really doesn't matter which one you choose as the base equation. But the book for this particular one said that they're going to use A as the base equation. Alright, so what they're doing, in the reason for that, is they're looking at, oh, I have an RP, TP equals this. I could plug that in for RP, and there's a TP here, so if I made this TP equals 12 minus TC, then I could replace that and put that in there. And then I've got an opportunity to try some other things. So this all comes with practice. It's not going to come real easy, and it's going to be a little bit difficult for most of you to do these. And again, you can use any of them, but let's go ahead and use that first one. So instead of RP, I'm going to use 3RC, since that equals that. And then I'm going to multiply it by, like I had here, TP equals 12 minus TC. So I'm going to use that in place of TP there. Alright, now see why I did that. Let me show you real quick. Because I made this a TC. When I multiply, when I use distributive, the key thing that I'm going to want here is I'm going to get a RC times a TC when I use distributive, which is what I've got here, because see, then when I do that, I can replace the whole RC/TC with a number. So that gets rid of 2 variables right there, which is really important to be able to do. So that's why I like substituting this in for here, is because when I do distributive, so it's kind of like a chess. You have to kind of look ahead at your next move rather than just kind of look at what's going on with the here and now. So I'm going to go 3RC TC equals 693. So let's see here. So I'm going to replace this with 165. So there, I just got rid of 2 variables really easy. So I've got 36 RC equals 3 times 165 is 495. And you do the math and you get RC equals 33. Okay, that's all. That's the hardest part, is finding the first variable. Once you find that first variable, then it becomes really easy, because then you're just plugging stuff in. So let's move that up here. So now that I have RC equals 33, I can take this equation and go 33 times T of C equals 165. Divide by 33, and then I go ahead and divide, and I get 5 there. So now I have 2 variables, TC and RC. So then I'm going to also take this here and write it as RP equals 3. What's RC? 33. So my RP then equals 99. So I've got a third one. Now what am I looking for? TP. So TP, I'm going to look at this one. RP is 99 times TP, equals 693, and therefore TP equals 7. So there's all 4 of my variables. And that's it for lesson 65. Now this is just going to take practice, lots of practice to get this down. And I hate to say it, but as we get into the book, we'll be doing more of these, and they get to be a little more challenging, but I thought we'd just kind of introduce them to you. You've got one practice problem, then you've got 6, 7, and 8. So you've got 4 of them to practice here. So hopefully after 4 times you'll kind of get this down a little bit.